Hi everyone, welcome to my channel Knowledge Center. Today we are going to discuss about a new concept in the aptitude, that is time, distance and speed. In short, we call it as a TDS. So now onwards in my video, further I won't represent it as a time, completely in time, distance and speed. In short, I will use it as a TDS. So I think I need to change the marker. Oh, it's too light. Let's change the marker. Okay. So let's discuss about this TDS. So in order to solve any problems based on this TDS, before that we should understand a basic concept on TDS. There are few formulas which we need to understand logically. See, as I recommend that you should never by heart the formulas. We have to understand the logic behind the formulas, then definitely you cannot forget any formulas in the exams. So let us understand the basic or logical formulas regarding the time, distance and speed. So to understand that, let us consider a person or a car. Say this is a location A. This is a location A and there is a car. Let us consider there is a car. Okay, so I'm just drawing it roughly, right? So there is a car, it has to travel and it has to reach the location B. So there is a distance between A and B. Let me denote this distance as D1. I just denote it as D1. And the time taken by this car to reach this destination B, let me denote it as T1. Okay, so it is moving at certain speed, right? So now I will consider the same car, but now the distance has been increased. From A to B, the distance has been increased and the same car is going to travel from A to B and it will reach this B. Now tell me whether this car will reach at the same time T1? Definitely not. It may or may not be. Now I consider it's not. I'll tell you why it is may or may not be. There is a condition. So now let's say take this distance as a D2 and the time taken to reach the car from this point A to B is time T2, right? So here by looking into this picture we can understand that if I increase the distance, time taken to cover that distance is also increased. By this I can write the relation between the distance and time is directly proportional. Time is directly proportional to distance. Okay, that's what I have mentioned here. That's clear. Okay. Now let's look into this matter in a different way. Now say distance has been increased, and now I don't want to increase the time. I want the same time T1. Means the car has to reach this B at the same time T1. Is it possible? First we need to understand that the car which is at A should reach B by passing this distance D2 at the same time which was taken earlier in this distance. So for example, say here if it is taking 1 minute to reach this B, I want same 1 minute time here to reach this distance D2. Yes, it is possible, but on one condition, that the speed of this car has to be increased. Okay, so here we get a relationship between speed and a time. See, if I increase the speed, the time is going to get reduced. Okay, if I travel with a high speed, we will reach earlier. Okay, we will reach earlier, faster. So I can write relation between those two. That is, speed is inversely proportional to time, or time is inversely proportional to speed. One of the same. So looking into this, we can get an formula. We can get a conditions over there. That is, the time can be given as, see, time is proportional to distance, so D by inversely proportional to speed. I can write it like this. So that is the formula. So you can use this relation, and using that we can write some more simple conditions like this. Time is equal to distance by speed. So that is the relation between the time, speed and distance. Or we can also say that speed is equal to distance by time. You take it over this side, it will be D by T. Or finally distance is equal to speed, and take this time towards this speed into time. So this is what the formula or relation we need to understand in case of an T, D and S. Okay. So, okay, now let's take up the one more concept which we need to concentrate on. So that is the unit of speed. So we all know, let's take this formula of speed. Let's see what is the unit of speed. Speed is given as distance by time. The unit of distance can be given as, I'll write it here, S is equal to D by T. So unit of distance is kilometer. How many kilometers? That is the distance. And per time, the unit of time is hour, H. So we can say that the unit of speed is kilometer per hour. But we consider this as a larger unit. If you consider the larger unit, that is in terms of kilometer per hour. But we can also have a smaller unit. Smaller unit in the sense, distance can also be given in meters. And time can also be given in seconds. So meter per second. So this is a smaller unit. This is the larger unit of speed. And this creates a complications or some twist in a questions while solving the question. Because whenever the problems are given, they will give the information about, they may give the information about distance in meter, and if they are given the time in hours, then you can't simplify it as it is. You can't take it like this, meter per hour. That is wrong. If you are taking hour, then it has to be kilometer per hour. If you are taking seconds, then it has to be meter per second. So that is the case which you need to be careful about while solving the problems. So in questions, they may give either this, or they may give either this, or they may mix up, and sometimes they ask you to convert it. Okay, so now let's understand how to convert these things. Means, say there is a speed A, and this speed is given in terms of, say, kilometer per hour. Now I want to write this in terms of meters per second. So how to write it in meters per second? So there is a, that is a speed. A speed unit is kilometer per hour. So let me write it in terms of meter per second. So we can do it like this: A into A as it is, not into, just okay, A into, write it, kilometer. In that you just want meter now. So kilo can be written as 1000. Kilo means 1000. Meter per hour. So per hour, but I want it in terms of seconds now. So for 1 hour we are going to have a 3600 seconds. So write it like this. So I got it. I have written this same parameter in terms of meters per second. Simplify this, 0, 0, 0, 0 cancel. 2 5s are 10, 2 18s are 36. Therefore I can say the speed has to be multiplied by 5 by 18, so that we can get it in terms of meter per second. So if any speed is given in terms of kilometer per hour, and if you want to convert that into meter per second, then that speed has to be multiplied by 5 by 18. That's the simple funda, right? So no need of just getting confused over there. And how we got that 5 by 18? As simple as this I have explained here. Okay, I hope this is clear for you. If it is clear, just press that like button over there. Okay. Right, meanwhile, now let's see inverse. So you can take the reverse parameter also. That is, if data is given in terms of meters per second, then I can get it like this: A into, take reverse, inverse of it, 18 by 5. This will give in terms of kilometer per hour. So if you want to convert from meter per second to kilometer per hour, then you have to multiply 18 by 5. If you want to convert kilometer per hour to meter per second, then you have to multiply 5 by 18 with the actual speed. Okay. So here one more logic I will tell you, a short trick to remember it. So 5 by 18 or 18 by 5, there that will be clear for you, but you may get confused about the 5 by 18 or 18 by 5. Okay. So look into this. If we are converting from larger to smaller, kilometer is larger, meter is smaller. Okay. So if we are converting from larger to smaller, then in numerator I should have a smaller number, 5. In denominator I will have a larger number. If you are converting from smaller to larger, in numerator I should have a larger number. So that is how you should remember it. It's a short trick, okay? But this is the basic way of getting the formula, logic. So these are the two basic concepts which you need to remember, or you need to understand, not remembering. Understand this to solve the problem, sir. So that was the formula for speed, distance, time, the relation I have given that, and this conversion, how we can convert that to kilometer per hour to meters per second, or meter per second to kilometer per hour. Next, let's take one more concept here, which is most important. That is the relationship of speed and time, which already I explained it. But let's see. So there are two. The speed of A and speed of B is given as A is to B. Let's say that has been given in terms of ratio. There is a car by name A, and there is a car by name B. Those speed has been given as A is to B. Then the time taken of those particular A and B will be 1 by A is to 1 by B. Time taken will be inverse to the speed. So as I already told you, speed and time are inversely proportional. So you can take a ratio. If it is given in terms of a ratio, if speeds are given in terms of a ratio, the time can also be taken in terms of a ratio, but it is inversely proportional. This further can be written as time can be given as B is to A. If speed ratio is A is to B, then its time ratio will be reverse. B is to A. This B will be here and A will be here, so we got B is to A. So this is the third concept which you need to understand. And the last one more important thing, let's see what is that. Say a person is moving from distance A, from point A to B, and he need to reach the distance C. Okay, so final you need to reach finally at point C. But here what I am giving one more point in between, that is B. Let's see what it is actually. Okay, so say a person is moving from point A to B at a speed x, a certain speed x, or it means 100 km per hour. That is an example. And after reaching this particular point B, he will increase or decrease the speed. He will say, let us assume that he is reducing its speed. Okay, he means after moving to certain distance B, he was very much of stressed and painful. So he will just go slowly now. Let's assume that he is going slowly. So he is going at a different speed. From B to C, he will cover that distance at a speed y. So here one simple logic. A to B is moving with certain speed x, and B to C is moving with another speed, that is y. So here the speed is not constant, speed is varying. So in this situation, we can find average speed. We can't say the actual speed because the speed is not constant here. Speed is varying. So we have to find an average speed of a person from one point to another point. So when there is a variation of two speeds, the average speed can be calculated as 2 into x and y speed by x plus y. Using this formula, we can identify the average speed of a person who is moving from A to C. This can be applied if the speeds are different. Okay, if speed is same, then we get an actual speed using speed formula. Speed equal to distance by time. Using that formula, you can identify it. Okay, so these are some of the basic concepts of time, distance, and speed, which are must and should required to solve the problems. So in next session, I am going to take up the problems and will solve the different type of problems. I hope it is clear for you. If it is clear, just press the like button and do subscribe to my channel. Thank you.